Hello everybody, welcome to this vlog. My name is Satya. So as part of this vlog, I will continue the discussion of routing basics basically. So in the last vlog I discussed about routing basics part 1. So on the screen here you would see host 1, router 2 and host 2. Compared to the last vlog, I've added few more details to the topology. When you call topology, it is the network diagram, right? So here I've identified host 1 by a single IP address, highlighting here, which is 192.168.0.2, and host 2 it is identified by a single IP address 192.168.2.2. So I told in the last vlog, which is part 1, I put here 192.168.1.2 for host 2. One thing you have to keep in mind that two interfaces on a router cannot have the same subnet IP address. It will complain. So you can give host 2 192.168.1.2, but you cannot reach from host 1 to host 2 by having an IP address of 192.168.1.2. It has to be a separate subnet, right? If host 2 is connected to router 1, then you could have IP address as 192.168.0.3, something like that. But since it is connected to router 2, you need to have a separate IP address. So then we discussed about and also there is a new thing that is introduced. Router 1 and router 2 have new IP address 1.1.1.1. That's a second IP address, and router 2 as 2.2.2.2. Now I call these IP addresses as management IP addresses. Here I have put, okay, I want to send data traffic from host 1 to host 2. That is what we want to accomplish as part of this training. But how to configure router 1, router 2? Host 1 you can log into 192.168.0.2. Host 1 can be a Mac laptop, Windows PC or a Linux machine. Host 2 also can be a Mac laptop, Windows PC or a Linux machine, and you can directly connect to them and configure the IP address. But how to connect to router 1? Routers are designed in such a way that they are more intensive in forwarding the packets rather than giving GUI. So most of the routers will be lightweight in providing GUI interfaces, right? So they will be having CLI, we call it as command line interface, through which we configure the routers. So router 1 will connect to router 1 using this IP address, either using SSH or Telnet. Router 2 we connect using this IP address, either to SSH, Telnet, and give a username, password, and then start configuring them, right, through those IP addresses. So now you say, if router 1 does not have an IP address, how to configure an IP address from the start? You can connect through a terminal interface, right, or console interface, and configure the router 1, router 2 to have management IP address, and then connect anywhere from anywhere and configure this router 1, router 2. Now let us get into the topic that we want to discuss. In last class, when I told we start up host 1, it sends the DHCP discover to router 1. For example, router 1 says I have an IP address 192.168.0.2. You can configure it. So there is a four-way handshake which is called as DORA: discover, offer, request, ACK. Then finally IP address will be configured plus the what is the default router for host 1. Default router for host 1 as per my network diagram is router 1. So it will say 192.168.0.1. So the first line is default route highlighted here is default route is 0.0.0.0/0 and it's pointing to router gateway IP address on host 1. This will be the route. Now you can say that you can have an explicit route for each subnet on host 1. That will result in scaling issues. You can't have millions of routes on host 1 because in internet billions of routers will be there. Then all these billion routers cannot be put in host 1. So that's why we use anything other than the subnet that is configured on host 1 go to the default IP address, which is highlighted here 192.168.0.1. Then we discussed about host 2 also. Host 2 also gets IP address automatically from router 2 through DHCP, and it configures the default IP address as default router IP address as 192.168.2.1, right? And its host 2's IP address is 192.168.2.2. Then in the last vlog we discussed about how we reached from host 1 to router 2 IP address, which is 192.168.1.1. Now host 1, when it is sending a ping packet from 192.168.0.2 to 192.168.1.1, here 1.1 is not the subnet that is configured here on host 1, so it will take default route to reach that particular IP address. So it will send a first ping packet to 192.168.0.1 IP address, and here to reach 192.168.1.1 you have to go on this interface, right? So we will send that packet to this MAC address. So that's how the ping reply happens. But the echo reply here will have problem because this router 2 cannot reach 192.168.0.2 because he doesn't know IP address. We can't have default route for routers because let's imagine this router 2 has one more interface connecting to router 3, and here router 1 connects to router 4. What if this link goes down, highlighted link here, if this link goes down, then it can go through router 4, router 3, router 2 and host 2, right, instead of going through this. So if there is a default route saying that always go through 192.168.1.1, then that will be a problem. To avoid that problem, router 2 will have entry for 192.168.0.0/24 subnet, saying you go through this interface to reach 192.168.0.2, go through 192.168.1.3 gateway IP address, right? And it will give a metric as 1. If we want to reach 192.168.0.2 through router 3 here, which is highlighted here, then you need to say metric 2. So lower the metric, it will be more preferred, right? So I have shown here for router 1 configuration for 2.0, but now for router 2 we need to add a static entry to reach 192.168.0.0 subnet. So there you can configure as per this topology. We are not having router 3 and router 4, so let's configure a static entry saying that on router 2 add static entry 192.168.0.0/24. That's what is mentioned here. 192 on router 2 192.168 0.0/20 on router 2 point to 192.168.1.3 gateway IP address. Then it will send the successful echo reply to host 1. Now that is what we achieved in the first vlog, which is router basics part 1. Now we want to send a packet from host 1 to host 2. Now the problem will happen here in router 1 now. How will router 1 know how to reach 192.168.2.2? Right? So to accomplish that, we need to add on router 1, add static entry 192.168.2.0/24 pointed to 192.168.1.1 with metric 1. So as per this topology, we always choose to reach 192.168.2.0 subnet from router 1. We use the next hop as this 192.168.1.1. From router 2 to reach 192.168.0.0/24, we use the next hop as 192.168.1.3. If we extend this topology to have router 4 here and router 3 here, then you can add more metric value, higher metric value, to which will be less preferred routes, right? So that's why we don't put a default route saying 0.0.0 go through this always this link, right? So then it will result in a problem. If this link goes down, then the routing of the packet will fail, right? Now let's send a ping packet from 192.168.0.2 to 192.168.2.2. Here ICMP echo request will be sent. So the first gateway next hop will be 192.168.0.1, for which op resolution will be done, and host 1 will have MAC address of 0.1, and you'll put it in destination MAC and send that packet from 192.168.0.2 to 192.168.2.2 to router 1. Router 1 receives the packet and he says the destination is 192.168.2.2, right? And here we added saying an entry to reach 192.168.2.0/24, use 192.168.1.1. He sends an ARP request for 192.168.1.1 on this link, right? Then after getting ARP response, he populates the ARP cache and he puts a destination MAC as that and sends without updating the IP addresses. It will be 192.168.0.2 to 192.168.2.2. The destination MAC will be MAC address of this gateway. Once that packet is received here, ICMP echo request, he knows here the 2.1 interface is this interface, whichever I have highlighted. So he says 2.2 is in this interface and it's the onlink prefix, onlink subnet. So we'll send ARP response for 2.2. Once he gets a ARP request for 2.2, 192.168.2.2, once he gets a ARP response, he will send the ICMP echo request here. Once host 2 receives, he sees that it's his own IP address, his destination, he will start preparing ICMP echo reply. Now here we need to have a default IP address. On host 2, default route is available for 2.1, 192.168.2.1, right? So he will send, ARP request was already sent, so ARP cache will be populated. He'll populate the destination MAC as 192.168.2.1 router address in the destination MAC, corresponding MAC address, and will send to router 2. Router 2 sees that 192.168.0.2 is the destination. He says here to reach 192.168.0.0 on router 2, you have to use 1.3. He sends an ARP request, or if checks the ARP cache, if it is there updated for MAC address for 192.168.1.3, he forwards it with the destination MAC as corresponding to 192.168.1.3, and ICMP echo reply is received in router 1. Router 1 sees that the destination MAC IP address is 192.168.0.2, which is an on-link prefix on this interface. So he checks the ARP cache, and if it's there, he'll send the packet to host 1. If it's not there, he'll resolve the ARP and he'll send the packet to finally to host 1. Then the communication ping packet of echo request and echo reply are received. Echo request is received by host 2, echo reply is replied by host 1. Then we can confirm that this topology is working fine, and we can send TCP, UDP, all those packets for data streaming. Right? So this is what I wanted to discuss as part of this vlog for part 2. In the next vlog, I will discuss why static routing entries are very difficult to scale, because there are billions of routes in internet. We can't keep on adding static routes for each op in the router. It has to be dynamic. So these dynamic protocols already I discussed in the first 6 to 7 vlogs: OSPF, BGP and ISIS. Intermediate system are the dynamic routing protocols which help in constructing the routing tables. Right? So friends, this is what I want to discuss. So if you like the video, please press the like button, and if you have any doubts, put in the comment. I'll try to answer to my best of my knowledge. And if anybody is looking for routing material, how the routing happens, then you can share this video, part 1 and part 2, and it will be helpful for them, I hope. Right? Thank you. See you in the next vlog. Bye.